Ladies and gentlemen, welcome back to the last session. It's now time for the Innovation Awards. The abundance of high-quality applications presented the jury of the BIOPOLYMER Innovation Awards with an exciting and challenging task again this year. We were very pleased with all the entries. The jury was made up of high-caliber members and discussed very constructively and enthusiastically. The jury was made up of the following people: my colleague and industry expert, Dr. Martin Bussmann, Simone Fischer, responsible editor of the trade magazine Plastverarbeiter, Dr. Patrick Hirsch from Fraunhofer Institute, and Peter Putsch, board of Polykum e.V., and Michael Walter from Wirtwein SE. After a multi-stage selection process, the jury nominated 4 companies as candidates for the main prize of 2,000 euros. 2 of them took the 3rd place. The high-quality samples submitted met the requirements and already have a certain industrial maturity before entering the market. The jury was, of course, very pleased about that. And now I'm very pleased to hand over the moderation of the Innovation Awards to my colleague Martin Bussmann. And during the award ceremony, the winners will present the projects and will be also available to answer questions afterwards. So now the stage is yours, Martin.
Thank you.
Thank you.
Thank you and welcome for the BIOPOLYMER Innovation Award ceremony. So, welcome back. To me, that's the most exciting point of the day. I was also told that people were really impressed as myself about the quality of the lectures today, and that's true. I remember back in the days, Peter, when we sat together, discussing about how can we make this conference more attractive, right? And one of the crazy ideas we had, and always sitting together with you, there's a bunch of crazy ideas popping up. We had the idea to bring up this award, to motivate people to get more access to the industry, to be more visible, and also to honor those developments who are on the way, on the cutting edge to commercialization in these upcoming markets. That was the motivation. At that time, we didn't have any sponsor or partner, remember? Nothing. We just said, okay, what can you contribute at that time from your lab of BSF, and what can we put together from the side here of the university and Exipnos? And so thank you again for the sponsors who also made that event even at a higher quality level as it is today. Also great thing was that the award was a kind of motivation thought by us to bring more people in and paying entrance fees. For luck, you found a different solution, bringing people here free of charge. And I think that's also a kind of great and innovative thing for conferences, to have more participants online also here who are not forced to pay high prices for high quality conferences. So it is this time the 6th edition of this prize. As you have heard today, that Jörg Dörstein of Biofiber received that award already the first time 6 years ago. Unfortunately, he's not here anymore, but he would have, or he told me that it was a great boost for their business. And that's exactly what we thought it should be, a boost for the business. And if we look back on the last year, we thought that the Bio Innovation Award should go to the product called Ceramelt. That was the best application we have received last year. Shortly before the ceremony, we've learned that Andreas, the brain of the project and project leader, became father and he was not there. You remember? Also crazy situation last year. And we handed it over to his team. This glue was really unique. It was a hot glue, thermoplastic hot glue, and was compostable. So we like to thank Andreas, who's most probably listening to us also this year, thank you for that. Great idea, great success. And we've brought a picture with us of him. Maybe you can skip the slides to see him receiving the award, at least. So that was the finalists and the award winners last year. And he received the award then personally as well in his lab. So that's the last year's first place. Coming back to this year and to today, we've had so many applications. It started as every year we've received pretty late applications, high quality applications from really different industries, different spaces. And I tried to picture that a little bit. It were products, processes, process optimizations, semi-finished products as well, adhesives. If we would dive into more precise areas of those products were from the sports industry and also from other industries as well. You can imagine if you have so many of those different types of processes on the table and the variety of the team itself, we had a quite hot discussion on what's first, what's good, what's bad, what's known, what's unknown, what's really cool and exciting, very emotional as well from time to time. And even if Frank has brought up a very kind of rational system on bringing points to every candidate and application, we ended up in the not known or first time situation that we got two prizes for the third place. And so this is today the first time that we have 4 winners for 3 prizes. And we like to show you as well in the application videos why. And I hope you can follow a little bit that out of this kind of mix of different areas and also different applications and subgroups, it was hard to pick. It was very uncomfortable to choose, and we tried to solve this issue as well in a very democratic way. Anyhow, this artifact was also submitted to the media, so thank you to you, Simone. The echo was quite interesting, wasn't it? At least to me, people were quite surprised about the 4 finalists for 3 prizes. That's what I got as feedback, especially on LinkedIn. It was interestingly discussed. But nevertheless, let's have a look and go one by one to the finalists. And let's start with the first finalist called Dirk Hollmann from Bad Doberan, from the company Cell to Green GmbH, which will make the first presentation. And so a first welcome to you.
Thank you very much. Before I start, I would like to tell you a small story, because I would like to give you an introduction why we do Cell to Green. It starts actually with Vietnam. Last year, you had the partner country Vietnam, and I went with my family to Vietnam. It was really nice. We went to Da Nang, to the beach, nice weather, nice water. So we dived in, closed the eyes, we dived in, and then my wife touched me. So it was really, really nice. But then I opened my eyes, and actually, this was not my wife. So this was a plastic bag. And I was a little bit feared about this one. Wow, because this is unbelievable. So you swim actually in a plastic waste everywhere on the beaches and so on. And at this time, I really thought, I closed my eyes actually and said, okay, so what happened actually to the world? So I'm a father of 2 kids, 2 boys, quite old. They're always playing some games, but this is actually what the future of them. So if we don't change the system, then it will be more plastic in the ocean than anything else on the ocean. So who did this? Unfortunately, me, because at this time I was working for a company or at the university on some plastics, on new plastics, fancy plastics, which is never biodegradable. And in this time I changed actually absolutely everything. And I said, like Albert Einstein, so we have to change the system, completely our thinking, and also my group was changing completely, and we said, okay, we start with zero, and we need something for packaging, which may be plastic, maybe not, but it has to have some properties, transparency, strengthness, and so on. And then after 5 years, we came out, and my kids were quite excited, and they said, okay, oh wow, Dad, what did you did actually? And I said, well, we developed something completely new, holistic ones. Okay, what means holistic? Yeah, holistic means it's a component which is actually coming from nature, is transparent after between, and then afterwards going back to nature. And this is something which you also teach here in this lecturing, but this is important for us to go to this way and so on. So we use actually cellulose and produce these kinds of transparent films here, which are biodegradable without any residues, so it's non-plastic actually, so there are no residues left in the environment, and further on it's recyclable. I come to this in some minutes. And the process is so easy, so even my kids can do the process in the laboratory. Further on, it's important here in Germany, you have these 4 tons, so you have to go to one of these tons. If you don't go to these tons, you always end up with the black ones. So in our case, it doesn't matter which tons you choose, you do the right one. But it's most important if you go to developing countries, so then you don't have these tons. Because then you have the earth or the sea. And in this case, our films degrade in days, 10 to 20 days and not longer. So it's not months, years, or something else, decades, something like this. Also in the ocean, it's degrading after 1 and 2 days, actually. Weeks, I'm sorry, fully. However, the properties are quite universal, so you can use different, we can fulfill different requirements, so we can make it flexible, we can make a sunscreen inside, and so on. So it's depending what you use inside the company. However, we don't provide only a sample, a foil, so we provide also some properties instead of recyclability. So we also provide this to the consumer because we can use our samples again, our foils, and recycle them. Further on, you get a digital footprint so that you know exactly how much CO2 you save, and this is also visible for the consumer, and so on. Actually, now in this moment, we're raising the first financial round. This is something which I would like to, not from your side, because we already have the company which would like to go with us. It's not an investor, it's someone who's saying, wow, this is cool technology, this is the future actually of packaging. And that's a dream team, quite only one chemist, one marketing guy, one sales guy, but we are unique because we think about the greenness and we would like to change actually the world. Thank you very much.
The next one to present is Thomas Lemke from D-Spec. That's an association of different companies called Glenpro, KTS, Neoplastics, and we are quite interested to hear about your product in depth. The stage is yours.
Dear ladies and gentlemen, we are delighted to be here today and to present our product. Thank you for that. So, we are a cooperation of 3 companies: KDS, Neoplastic, and Glenpro. We know each other from a network, and we love combining our competences. So, Hubertus Frankenstein is the managing director of Neoplastic, has the manufacturing competence. Achim Henke. He couldn't join us today, but he is online, I guess. I hope so. He is the material specialist, and my name is Thomas Lemke. I'm from Glenpro. I'm the managing director of Glenpro, and I've been responsible for the design. So, okay, it works. Our product is about biopolymer wildlife bite protection for conifers. So, to give you an overview what it is about. As you can see on the photo, the deer eats the young shoots of a tree, and but if the main shoot of a tree is not off, the young tree stops growing for up to a year, and after that subsequently grows more slowly. So this is a tree which got bitten by a deer, for example. So secondly, it develops side shoots, and this reduces the value of the tree if the wood is later harvested. Therefore, we dedicated ourselves to the topic bite protection. So first of all, we inquired about existing solutions. One is regulating the population of wild animals. Another one is spray technology. Remains less than 6 months, and depending on the weather conditions, but it also contains non-biological substances like chlorine. Another one is clamping solutions. It doesn't grow with the tree and needs to be readjusted. And at the end, there are fences also possible, but they are very expensive, need high efforts, and do not give any guarantee to keep wild animals away. Our solution, Bite Protection GoPro, with its major requirements. How did we get there? We sat together and brainstormed about the design and the material requirements as follows. First of all, you see some pictures of the CAD models we created when we sat together. So this is in a chronicle order. That's the next one. This comes closer to the final shape, and this is the shape we used for the injection mode later on. So we defined the mechanical requirements such as it has to grow with the plant and shall not affect its growth. It must be a lightweight design, because the weight is also important for the main shoot. If it's too heavy, the main shoot won't grow vertically, it will grow horizontally. It has to remain on the main shoot for more than 5 years. It needs a good flexibility, for example, to ease the assembling. It must not accumulate heat or moisture, and it requires a good air, light, and water permeability. And it has to be at the end an economical design. So the material requirements are another base of our product. Due to the use in nature, it has been a must for us that the material is bio-based, as well as biodegradable under contact with the soil, according to the mentioned ISO. The weather resistance over more than 5 years has been another task to fulfill. We required good mechanical properties in the temperature range between -20 to +40 degrees Celsius. To make it visually deterrent for wild animals, the color blue has been another requirement. And the photo you can see is the assembling of the serial part, which has the required properties. So the final thing what we had to do is to validate the parts. So during our development, it we had to do it under real conditions. So we were lucky to use the forest of a friend from Hubertus, and at first we tested 3D printed prototypes to see how it works. For comparison reasons, we used only chemical on a few trees, and we had the key experience then that the trees with our bite protection still had their main shoots, while the trees with the chemical protection didn't have any main shoots anymore. So after that, we made the next steps using the design, the latest design, and tested on different conifers. In this case, you see a black spruce and a blue spruce. And the final test row occurred with injection molded parts with the Cirrus material as well on various conifers. Okay, thank you for your attention.
Now we have the pleasure to present Tobias Irkens from Schwerte to the stage from the company Greenfoil Nature. Greenfoil sounds a little bit similar like Dirk's one, but you'll hear pretty soon that it's much different than that. So please give us insights about your interesting thing.
Welcome to the presentation, and a warm welcome to everyone listening to this presentation. I'm even more pleased to present our innovation to you as one of the award winners. My name is Tobias Irkens. I'm a licensed pharmacist, co-founder of the Greenfoil Nature, and I will guide you through this presentation. So, what does Greenfoil Nature do? Greenfoil Nature works with algae. As you can see on the left, we are working with the plant in total, or as you can see in the middle, we are using extracts. On the right, you see a package containing a very high amount of our innovative additive for decaying and degradation processes. It's worth mentioning that our products come from 100% natural resources, are 100% biodegradable, and can be used from industrial to medical appliance as well. Now, let's talk about our GFN biodegrade additive. Our additive accelerates the degradation and the decay of bio-based materials. It's 100% natural and meets the single-use plastic directive as well. Furthermore, it's home and marine compostable and has been approved for direct contact with food. Our product is available as a powder or in a compounded form, and as you can see on the right, there's a bioplastic that has been modified with our additive, and as you notice, there are some little cracks. So what happened here? Based on the question on pharmacy, how do I get a drug disintegrated at a desired place in a desired time? We are using various technologies to modify and to program the decay and the decomposition of bio-based materials. Let's get into this scheme. In contact with water, the entire matrix will swell up and there will occur some cracks and the surface will increase substantially. And this allows, for example, microorganisms to colonize and thus to speed up the progress and process of decay and degradation. Now, let me demonstrate you the mode of action. A short introduction. This film contains a high grade of our additive. I'm going to cut it into two pieces, put the first one in common tap water, and I can prove it's tap water. I can take a sip if you want. And the second one I'm going to activate with our retarding agent. And let's see what will happen. As you can see, the breakdown has started immediately. So what will happen to the second part of the film? when I put it in tap water as well. As you can see, there's no breakdown. This is because we are able to program the speed and the progress of decay and decomposition. We're controlling various parameters of this process, and it can take a few years if you want to break down the materials, depending on your own or on the customer's requirements, and of course depending on the environmental parameters. So we are looking forward to hearing from you, and let's get in touch.
And now it's up to the last group of finalists to present the product. It will be Vitus Zenz from the Technical University of Rosenheim. Welcome on stage, and we are happy to see, oh, you're also coming with samples, very good, to see the next exercise and see how your products work. Welcome.
I want to start actually by thanking a few people, because I'm sure that I will forget it afterwards. So I want to thank my two professors who really supported me during the last years, and it was quite a long process to develop this stuff, and I'm really honored that they supported me so good as they did. And I want to thank my PhD colleague, Adrian Cray. He's not here with us because he's at the Achema. But yeah, he worked on the process quite a lot as well. All right, so today I want to present to you a new process that we developed to produce succinic acid. A new process to produce succinic acid directly from biomass, from wooden biomass, and let's get right into it. So we wanted to basically develop a process that can directly produce succinic acid without the need of fermentation or microorganisms. As probably many of you know, that's the main and the only type of production of succinic acid based on lignocellulosic biomass. And we thought, well, we could try at least to do it purely chemical. So what we come up with was that we took a twin screw extruder, normally used in the plastics industry. It's a continuous production machine, and we did take some lignocellulosic biomass, put some water and catalyst in the twin screw extruder, and then we processed it directly through the extruder. But the trick here is that we not only used catalysts, we also used microwaves. And the microwaves are helping this reaction quite a lot, because as you probably know, the reaction or the transformation of wooden structure into succinic acid can take quite a lot of time. And with the microwaves, we were able to bring it down quite a bit, so the reaction time. So in the end, we get succinic acid, and as all of you know, we can produce the biopolymer PBS from that. All right, so we did not start by directly going into a twin screw extruder. We did some pre-tests with it, and what we did is we took a microwave batch reactor, and we put some sawdust directly from the sawmill, so it was no treated sawdust or no treated biomass. We directly put it into the batch reactor, and then we had like very short reaction times. We put in some different catalysts, and one of them worked very well. And we got a yield, a direct yield of succinic acid of around 60%. That's weight percent. So in a direct conversion. And as far as we know, that was the first time that something like this was done. Yes, just a quick overview. We didn't want to scale up the batch process, because for us it was obvious that this is not the way to go in basically in the large-scale production. That's why I developed the continuous conversion. And the real good thing about the continuous production is that we can scale up the different extruders quite well. We can take basically a bigger extruder that's like very common in the plastics industry, and we can put some microwaves on it, and then we have like a lot more throughput. So that's a very, very useful thing that we can do in the later stages. So, and what you can see here is that's the actual prototype, and you can see the different microwave generators bolted basically onto a twin screw extruder, and we create like a very large reaction zone, and we tried to, or we did mimic the, or we did almost the exact same reaction that we did in the batch, and that meant that we could produce, honestly 2 weeks ago, it was very shortly before this presentation, we did produce the first samples, and we could confirm that we produced succinic acid with this method. And from there, yeah, let's see where this goes. We tried to improve and optimize the process even further in order to get to the 60% that we did with the batch process. But we're very happy about this result, and let's see where it takes us. So thank you for your attention, and let's hand over. Thank you.
Very different topics, very different categories, very innovative, all of them close to the stage of commercialization with good aspects to really do that. But before doing so, I would like to welcome Peter on stage as chairman of Polykum e.V. So give him a warm hand.
Yes, okay. I'm very much excited. Now you get the places 1, 2, 3, 4. No, 4 not.
There's no fourth place, Peter, today. But we're going to start with the last ones, which are the third ones, all on the same equal level for us as jury. And for us in the jury, as said, technical feasibility, also status of the development in terms of commercialization, readiness to commercialize and bring it to the market, were those aspects. Please come closer. Also, the status of certification, also fitting to the biopolymers definition as we as jury have defined that, and that was also a very interesting discussion we had in the jury. What is a biopolymer if succinic acid is part of it, or cellophane films? And we said everything what is contributing to a biopolymer, moving that industry forward, is into that category, what is of interest for us, and this is why your applications are amongst the finalists.
Actually, we were looking up our conditions for the prize to figure that out. Yeah?
That's true. That's true. I see the smile also in Patrick's face. Yeah, it was, as said, it was a very long morning session we had with quite good discussions walking through that. But what we also considered were the costs of everything compared to conventional plastics, moving that forward. Also, the kind of engineering trickiness applicable to existing technologies and processes, patents, and also sometimes, in some cases, this kind of spin-off type from university, really research for really practical things. And that's what we like to support. This is how we define and see also the biopolymers activities in Polykum, and that's what it is about.
Correct.
Correct. I like your long words today. So, starting with one of the third prizes. We as jury, we found that solving plastics issues in the environment is something very crucial. We need to start somewhere. We need to remove plastics from getting and really being spoiled in the environment and improve the coexistence of humans, animals, and trees. And what we also liked on the solution is the cooperation, the design of this specific part. I think we in the jury, we've seen some of those identical things, as you've mentioned in your lecture already there. But yours is really brilliant in terms of designing, engineering, and also the combination of bioplastics engineering and bringing this coexistence into balance. Also, the commercial success with this no further costs involved. Nobody needs to take care afterwards. You said you can also set up a fence. Yes, you can, but you need to remove it at a certain stage, right? Even if you want to bring up this high cost. So for us, that was really, really interesting. We like to welcome on stage the wildlife bite protection guys for this really, really interesting development. Herzlichen Glückwunsch. Herzlichen Glückwunsch.
Short break before I hand it over. I have an important information about this trophy. You remember last year the winner was the TETK with the glue from Andreas' team, and I asked him to send me the glue, the biological glue, to glue together the PBS plates. So besides the metal piece, this is all bio-based and biodegradable. So it's an honor for me to hand this over to you. Thank you very much.
Mikro voor Sven.
Oops. So, that's for the press.
We like that different disciplines work together. And so the third award, we liked most about that it's a cooperation of pharmacy, chemistry, and engineering. Regulation was steering that process of biodegradation, and to control that is really magnificent. That was always in our work life, Peter's and mine, one of the key challenges. When is the start to define, to break down this stuff? Because we always had customers saying it needs to work as a constant plastic, and then if it sees a kind of trigger, it needs to disappear. So for this kind of magic, and to control this magic and bring it from a different discipline, for us as jury, that was magic somehow. But since it's not magic and you disclose to a certain extent what it is, we liked it very, very much. It was also a long year development of 4 years, you reported to us. So it's really great to see that after such a long time and all the certifications you've obtained with that, you're ready to start to commercialize. So that made us very happy, and this is why we like to honor that with the third prize, the BIOPOLYMER Innovation Award for Green Foil Nature. Please.
So now I have everything and the certificate. Is it the right?
Glückwunsch.
Danke.
Glückwunsch.
Glückwunsch.
Now, if we reveal the second prize, everybody know who's the first, because there are only 2 left. So the tension is at its max, but being gone soon. As said, the last 2 ones we liked about we love the technical details, to really go into some areas with passion, and also to point out at the end that it's technically feasible and doable. So that's what we still honor, and that's the similarity of both ones. So talking more about the second one, the technical details I love very much. I like that it's applicable on technical thermoplastical machines. you've reported that wood waste could be processed at a wood processing facility to produce chemicals. And that's something what I like personally very much. That's where I looked into the last years of my work, and I think this is very revolutionary. It's not a plastic, yes, it's succinic acid, where most of the people need to look up what it is. But if they look up what it is, they'll find out that biopolymers can be made out of that, and novel things can be done. And so for us to increase the harvest from roughly 35 to 40% up to 60-70% you reported was outstanding. That's incredible. And to use such a fast machine like an extruder right away where the waste is going to be produced at a wood mill or something like that, that's really revolutionary to us. It requires small space, and I'm pretty soon if you optimize that and work further on that, that can be installed, and that could be a kind of revolution for the bioplastics industry from our side here. So let's welcome Professor Strübe and the team for the second prize. Herzlichen Glückwunsch.
Before I give it to you, I must say that Michael Walter would like to stand here as well. He regretted it very much that he cannot give you, because he knows you personally, and I shall give you his greetings. Okay. So here is the trophy with the BioClue. The certificate, and here's the handshake. Glückwunsch.
Ein bisschen rüberrücken. It's not longer a secret that Cell to Green is, for us, the first prize winner of the Biopolymer Processing and Molding Award 2024. Dirk Hollmann and the team has shown us that with low energy costs, the production can be of the same class and film as conventional plastics. It's a new step into this cellophane world, as it is known before. There are multiple adjustments possible without using toxic substances, without blending something old school into something new school, how I would call it. The way also to process it easily, starting from university ideas into semi-industrial steps now and hopefully into the full industrial scale, impressed us quite a lot. There are also nice patents filed to protect your idea and to allow you to step forward. And yeah, this is what we like the most as jury, and this is why we see you as the winning candidate #1 for this prize. Dirk, please step forward. Herzlichen Glückwunsch. Vielleicht für die anderen beiden.
So, okay, you hand over the trophy. And you can realize that the only one that looks to the other side. Here is the check.
Congratulations. We'd like to invite all winners here in front to make a photo of everyone and of all the teams. Please give warm hands and applause for everyone. Thank you so much, because last year sometimes we missed that or didn't make it properly. Thank you very much for filing your application. Thank you also very much for the others for filing the application. And we hope that those kind of good results, as you can see them here, will motivate others to also file their ideas next year for the Biopolymers Innovation Award, also from all over the world. I'd like to highlight that again. We had international involved internationally, but I like to see that also on stage next year.
But now we have some Franconians, some
Yeah.
Bavarians, some
Peter, real international, you know.
Really national.
I had to say that.
Yeah. Good point.
Okay. I also want to mention that all the finalists will get a certificate by post, so that we must say that all were winners. So we wanted also to send the certificates also to all finalists, because it was a great selection this time. Yeah, thank you.
Yeah, thank you very much. And with a warm hand of applause, let's bring you back to your seats. Thank you so much.
And now, ladies and gentlemen, dear audience on site and online, that was this year's BIOPOLYMER Congress. We do hope it's been informative and enjoyable, and that you'll take away many new insights and ideas. Thank you so much for your attention, your interest, and active participation. It was really, really great having you all here and online. And next year we are planning another live event where we can exchange ideas and network and direct contact. But we can already tell you this much. Poland will be our partner region 2025. I'm very much looking forward to this because I am from Poland. So, and you have the time and the desire, we would be very pleased if you would give us a short feedback on our Congress so that we can continue to improve next year. You will also have the opportunity to do so in the email you will receive from us after the Congress. And we would like to thank you in advance and look forward to receiving your feedback. Many, many, many thanks to our great sponsors and partners, the Federal Ministry of Economics and Climate Protection and the House of Transfer. A big thank you to Australia and the Australian audience and the University of Queensland, and to everybody who was here, who was online, who was watching and participating. It was a great honor to have you here as a partner country, and that some of you have traveled halfway around the world to be with us. I hope the journey was worth it. Thank you for joining us. And many thanks also to the Fraunhofer Institute for Microstructure of Materials and Systems, Exypnos, IMG, Digilab, and Kreslin. And finally, we would like to thank the Georg Friedrich Händel Hall once again for the outstanding support. We are indebted to this wonderful team. Without them, this event wouldn't have been possible. Many, many thanks. And we look forward to seeing all of you again on June the 17th in 2025. Take care and stay healthy. See you next time. Goodbye and
Stop. I want to thank you, Julita, for the very nice moderation. That was
Thank you.
It's getting better every time. I mean, it
so
was
much.
good. It was good all the time, but now it's was outrageous moderation. And of course, to you, Martin, for the award laudatio and your help during the moderation. I think you both are an excellent team. And I want to thank also our Exypnos team for everything. I mean, we worked half a year to get this Congress like it is. And they did a great job, and we had a nice design, nice new design, new website. All the work was done in time, and even the glue was sticking.
For sure.
Well, yeah, of course. Otherwise, he wouldn't be the winner from the last time. Yeah. Okay. Thank you very much to the audience, also to the spectators worldwide. And yeah, we are waiting for your. It's actually It is the 17th of June next year, and the party will be on the 16th of June in the evening, like this year as well. Let's say the opening ceremony. So, and the Congress will be again on the 17th of June next year. Thank you. Have a safe trip home, and thank you to the whole world for watching us. Thank you very much.
Thank you very much. Thank you.